Algebra 1, notes number 22 says graphing using slope-intercept form. This is one of the easiest way to graph. It says your essential question, how do you graph an equation with slope-intercept form? And to answer this is to graph an equation in slope-intercept form is to plot the intercept first and then use the slope, the rise over run, to plot your other points. Okay, vocabulary word, there's slope-intercept form right here. Is the way of writing it, which we've been writing, I just have not called it this, was y equals mx plus b, where the m is going to represent the slope of our line that we've been using, which was our rise over run. So we're actually going to officially say that is the m. And then we have the b, which is very, very unusual, but they have a b here, represents our y-intercept. Remember, the y-intercept is where it crosses the y-axis. So this b is actually going to be some coordinate that you'll actually have on your graph as a y-intercept. Okay, and then our other vocabulary word before I go on is parallel. And realize parallel means you have two lines that are in the same plane, but they never intersect each other. So we may have equations that are actually going to be parallel to each other. So we got to watch out for that. Alright. Here in their picture, here is our description here that's pulling apart. Realizing that if I tell you to identify the parts, the value that has the x, yesterday we were calling it the a, which was the constant of variation. It also has the name of slope, which is the m, which is a more common name of slope, m. And then the constant out here by the self is going to be called our b, which is our y-intercept. Therefore, on our example number 1, we have 3 parts to it. We want to identify those 2 parts of this equation. If I look at the first equation, this is not written in the proper form. The proper form has the x first and then the constant behind. So what I'm going to do here is just rewrite this so that the negative 4x is in front and the 10 is behind. That 10 is positive, so I'll put a plus sign. And then if I identify my parts, I look for the x. I have a negative 4, and that's going to be my slope, so I'll put an m equals negative 4. And then my y-intercept is the constant that is written, and that one, whoops, wrong pen. That is my b, which is going to be 10, and there's my 2 parts. On the second example here in the center, this is not written in slope-intercept form, so that means I must move the x to the other side first. So I'm going to draw my line. This is a positive 2x, so that means it changes to a negative. 5y drops down, and then I have a negative 2x, and the 10 slides behind it. The y is still not by itself. I have that 5 attached to it, so that means I need to divide everything by 5. And so now I have y equals, and I have this fraction, negative 2 over 5x plus, and 10 divided by 5 actually divides to a whole number of a 2. Now I have it in slope-intercept form. I need to identify the m and the b of my equation. I look for the m is always with the x. Here it is a fraction, so I'm going to copy it down, negative over 5. And then the constant, that's the plus or the minus out on the end. This one has a plus 2, so that means my intercept is a 2. The third example, this is still not written in slope-intercept form, so I need to rewrite it. Here, only thing I need to do is get rid of the negative 4 from the y, and since this is a multiplication, I'm just going to divide by negative 4. And here I have y is equal to, and 16 divided by negative 4 is negative 4. Now this is still not written in slope-intercept form, but it's pretty close. realize there's not an x at all. If there's not an x, that means the x is a 0x, and I have a -4 on the end. Now if I want to identify the m and the b, I look for my x, and there's my 0. So my slope is 0. And I also have a minus out here on the end. That same thing, that's going to be my constant. So that represents my b-intercept here. And there's my two answers. You realize that this follows through with the fact that this doesn't have a slope. This was a horizontal line that went on my graph. Alright, example 2, we have 3 graphs that we're actually going to plot our points and graph these lines. I need them to be in slope-intercept form to actually use what we have above. And there's one thing I'm going to add to this. If I take the first one, I don't have a number in front of the x, so there's an understood 1. And this 1 here represents my slope, so I'm going to write it underneath here. It needs to be a fraction, so I have a 1 over a 1. And then the b is going to be the -7. So right here on the side, I'm going to show you something a little bit. The b, we said, was -7. That is my y-intercept, so that means that is a 0, -7 that I'm going to plot. And then my slope was an m. Remember, this is your rise over your run. Now, these letters are Greek and Latin terminology that absolutely mean nothing to me, having a B and an M. So I reference these things as the B being where you begin on your graph, and after you have that point, the M is how you move on your graph. So this is where I represents the B and the M here from this equation. This is just my invention. This has nothing to do with the historical mathematicians. So if this is where I begin, I'm going to first plot 0, -7. Okay, at that point I'm going to put a dot. From this point now, I'm going to move on my graph according to the slope, which means I'm going to go up 1 and right 1. Up 1 and right 1. Up 1 and right 1. I'm going to keep following that pattern until I can see exactly where the line actually exists. Once I have it, I'll take my straight edge and I'm going to actually draw it. Make it solid. These are continuous, so make sure you put arrows on the ends. Okay, if I go to the middle one, this is written in the correct form, so the M is a whole number of a 2. I have to make it a fraction, so I'm going to put it over 1. And then the y-intercept is going to be 0, -3. So remember, this is my B, that's where I begin. So I must plot this point first. 0 and -3 drop straight down. And then from this point, I'm going to follow it according to the slope. This is how I move. So I'm going to go up 2 and right 1. Up 2, right 1. Up 2, right 1. And draw your line. Realize this is not using the calculator at all. A way of graphing. I don't have to put it in Y1 and look at the table and find points. This is a straight way to graph it without even using a calculator. Okay, on the last example here on this page, I have a slope that is given to me that is already a fraction. So I'm going to use that 2 over 3. And then they give me the coordinate where I start. This is a -4, so make sure you put -4. This is where I begin. This is my y-intercept. 0, -4 is right here. And then from this coordinate, My slope is how I move, so this has a positive 2, so I go up 2, and then to the right 3, which is just counting by 2s, it makes it a little difficult. So be careful. 2, 3. Very, very careful in seeing where it is. If you want to draw the stair steps, feel free to do so. And what I mean by that is doing this, making your little stairs so you can see the slope. This one goes up and over, up and over, up and over, so you can see the steps. Up one, over one, up one. These are little bitty steps. Over here, the first one. If you want to see your stair steps, that is by all means okay. It will not be wrong. Okay. On the next page, you have example 3. It says determine which of the lines are parallel. To be parallel, up here I didn't write it, they do not intersect, which means their slopes are the same. Okay? Also means slopes are the same. If they do not intersect, their slopes are the same. So if I look at my lines, they say which one of the lines are parallel. Oh my, let's see. I'm going to take the first line here. So I'm going to label that one number 1. I'll use purple with this line. The middle line, I'm going to label it number 2. I'll use my dark pink. And then the third line, I will use orange for the third line. And if I go back to my purple, if I'm looking at this is counting by 2's on the Y scale and 1's on the X scale. So if I visualize going from the top point to the bottom point to find my slope, I'm going to say, well, I hate to go through the lines, but we're going to go that way. This is going up. There's 1, 2, 3, 4, 5, 6, 7, 8. So it rose 8. And then from there, these are 1 increments, so that would be a 1, 2. Okay, I'm looking at slope. Let me change pins. Going to line 2, I have a big long jump, so here we go. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It looks like it moved 12 up. And then it goes over 1, 2, 3. Oh, these are going left, so that would be a negative, and this top one would be negative also. And then let's go with our third line. This goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, it appears. And then from there it goes 1, 2 and a half. Is that what that is? So 2.5. And it went left, so it is negative. Okay. Alright, I'm going to grab my calculator here. And, oops, got to turn it on. I'm going to take the first one, 8 divided by negative 2. I'm going to math bracket and see that this is equivalent to negative 4. Okay. I'm going to take the second one, 12 divided by negative 3, and math bracket and see that it is equivalent to negative 4. And then I'm going to take the 9 divided by negative 2.5 and math bracket and see that it is a strange thing of negative 18 over 5. Okay. So if on the front page I said, alright, parallel lines right here, whoops, let me slide it. Parallel lines have same slope. Okay? Parallel lines have the same exact slope. If that is the case, which lines have the same exact slope? Well, if I'm looking at it, these both have -4, so that means line 1 and line 2 are parallel. And there's my answers. Okay, if I go into example 4, it says, okay, two of the graphs of the equations are parallel, but here they didn't give me the pictures as they did up above. They gave me the equations. The first equation is y equals -3/5x plus 2. And if I'm looking at this, is written in slope-intercept form, so I can say the slope of this line is exactly -3/5. The second equation as 5y plus 3x is not written in a nice form at all. So I need to solve for y. Well, which one has to go over? Realize I need to move the x to the right, so I'm going to subtract 3x. That gives you 5y is what drops down, equals, and I'm going to have -3x plus 8. The y is still not by itself, so now divide everything by 5. I have y equals -3/5x plus this 8/5, which you can do a decimal if you like, which would be 1.6 if you prefer. And then this is written in slope-intercept form. The m is -5/3. So if I look at this, the top one has a slope of -3/5. The bottom one has a slope of -3/5. They are exactly the same, so what does that mean? Okay, what it means is they are parallel lines. Alright, let's try again on the second one just to practice this one more time before I quit. This has 2x plus y equals 5. Is this written in the correct form? No, it's not. So I'm going to drop my line down and move my x to the other side. So I'm going to subtract 2x. So I have y equals, and remember I'm going to slide the 2x in front. The 5 goes behind. This is a positive 5, so I'll make it plus. And now this is written in the correct form. My slope is what? -2. If I look at the second equation, I have -6 plus 2x is equal to y. Is this written in the correct form? And so, well, it's pretty close. I've got the y on the right side, which it needs to be on the left, so I'm going to flip this. We have y equals, and then I'm going to put this side in the other direction. So these guys are just crisscrossed. And now this one's written backwards, so that'd be y equals, I'm going to put the 2x first and the -6 behind. Realize that negative makes it a minus. And now it's written in the correct form. It's good. I can identify the slope. So the m is what? 2. Okay, so if I highlight them here, my slope of the first line is -2. The slope of the second line is +2. So are those equal? I would say no. These lines are not parallel. No. Okay, make sure you answer your summary for your essential question on how you graph using slope-intercept form.